Okay, I think this is number 9. This is test review number 9. Okay, test review number 9, fluids. Okay, now, this is a river. It's flowing. Okay, so the river is flowing this way. Okay, it's flowing left to right. Okay, now, when it hits this narrow spot here, is the river going to get faster or slower? Faster. It's going to get faster. So the velocity vectors we can draw in like this. We could say that the velocity is here. Okay, these are velocity vectors. So it's like here, and then as it gets close to here, it's going to get faster. Correct?
Yes, sir.
Then it's going to slow down again, right? Understood? So those are velocity vectors. Yes or no? Easy? Now, there are bubbles in the water. There are bubbles in the water. Let me draw a bubble. Okay? Is that bubble going to get larger or smaller as it gets to the narrow part of the river? Is the bubble going to expand or contract? It's going to contract. Is that what somebody said?
Yeah, I did.
You did? You said that? Okay. What's Bernoulli's principle? Now, I made some lectures on YouTube that explain in detail what Bernoulli's principle is. Anybody remember what that is? What is Bernoulli's principle? Bernoulli's principle is, feel better a little bit? It's an awful perfume. Somebody's wearing something very perfumey. It stinks. So Bernoulli's principle is, as the velocity of a fluid increases, the perpendicular forces, the perpendicular pressure and forces decreases. For instance, if I had a hose, here's my hose, okay? The hose, let's say it's not flowing, right? It's coming in this end here, but it's not going out. So pressure's building up and it's swelling, right? And there's a hole in the hose. And what's it going to look like? What's it going to look like? Yeah. Water's going to shoot out. Right? What happens if I increase the flow? In other words, I turn on the nozzle, I squeeze the nozzle. What's going to happen to the flow of water through here? It's going to become faster or slower? It's going to become slower as I open up the nozzle, so the water's not going to flow as I open up the nozzle. Does that make any sense to you, Zach?
Faster.
It's going to get faster. So what's going to happen to the leak?
It's going to decrease.
It's going to what?
Decrease.
Yeah, it's going to decrease because the pressures and the forces are lower as the fluid moves faster. Correct? The perpendicular forces to the flow. In other words, here I have a flow. These forces here are less. If it's just a little bit, flowing a little bit, they're much greater. Correct? Yes? Yes? So what's going to happen to these bubbles as they reach this area here? Are they going to contract or are they going to expand? They're going to expand because the perpendicular pressures are lower here. So here I have a bubble here. And as the bubble gets closer, Okay? As the bubble gets closer to this area where the stream is moving faster, the perpendicular pressures, forces are less. So it doesn't have as much pressure to reduce the volume. High pressure, low volume, right? Here, low pressure, large volume, correct? Boyle's law, yes? This is another example of okay? This is number 9. Pretty straightforward, easy?
Yeah.
Pretty easy, yeah? Okay, excellent.